Well, this is the tutorial about I-type and J-type MIPS instruction. So as I said during the first tutorial, while we're studying the R-type, so we have three tables: MIPS register set table, the opcode table, and the function table. Okay, so this is also required for any type of instruction to get the value of the instruction itself. Well, let's discuss an example of I type. I stand for immediate. That means some data that you use to execute the instruction already within the instruction. That means within the immediate value. So here is an example of I type, and the instruction name is add I, or you can say it add immediate, and the format is $S0, the register, $S on another register, and the immediate value. Well, so you have the opcode, different opcode for these. You find in the opcode table, and for add I it's 8, and we have two register, RS and the RT, while the RT is the destination operand and the immediate the value, and then RS is the source operand. So what it actually happened, so once you execute the instruction, there is some value in register S1 that is added with the immediate value. If for example the S1 having 10, so 10 will be added and the result will be 15 is stored to the destination register S0. So here is the bit length for the opcode is always 6 bit, and 2 register 5 bit, and the 16 bit immediate. So here is the another example: add I, register T0, register S3, and the immediate value is -12. That means so -12 is added with the value S3 and stored the result to the register T0. So in that case, RS and immediate is org as a source operand, while RT is the destination operand. So if you convert this value to a binary, you will get this value. But remember, once you convert this minus or negative value, you need to format the 2's complement format of the binary. So 2's complement, the first you need to convert this 12 to a binary, and then make the 1's complement plus 1 to make the negative number here. So this is the instruction for the second. Well, so what if it also executable when it is a memory operation? So the load word means you have to load some value from the memory. So to execute loader, you must have to know the address of the memory, and the immediate is added to the register to generate the address of the memory. For example, here you can see the load word T2, 32, and then the register. So here is 0. That means 0 will be added to 32. So it will add the data of the memory where the memory address is 32, because this is 0, always 0. On the other hand, this is the store word instruction. At the same time, that store word means store something to the memory. So in that case, you also need to know the address of the memory. And here is the immediate value and the address of the memory that is stored in another register. So you can conclude that RS and immediate is the source operand for RT, and RT is the destination operand for add I and the load word. However, RT is another source for the SW or store word. And once you convert this value to a corresponding binary, you will get this 32-bit instruction. Well, the last is J-type. Basically, J-type is a unconditional branch that is detailed discussed in the next video. that means branch. There is another tutorial this regarding the branch where we discuss two types of branch, conditional and unconditional branch. And within the unconditional branch, the J type, the jump instruction is discussed here. So here you can see that the opcode is 6-bit and then 26-bit is the address. So jump means you have to jump the particular address. So one thing is very important to know here. Here is a 26-bit address, and you know MIPS address is 32-bit. So how you can get the 32-bit from the 26-bit? Okay, so that has been discussed in the next video. So here you can just have an example with a J type instruction as a J instruction. Look, so this is a sequential instruction that add immediate, that means add 4 with the register 0, so and store it the S0, so we can get the S0 is right 4 right now, and then add I1 with S1, then we find the S1 is 1. Then say J target, so this is the level, so regardless of the condition it jump to the level target, and then start execute. Without executing add I, it start execute the value at S1, S1, S0. That means the value of S1 is update with the value of S0 and S1, and it update by 5, and then it works like this. So on confusion thing here, the jump register, so where the register contain the value of the address is not the J, is a different instruction. So this is one thing you need to keep in mind. So we can conclude with that. So we have the conditional branch, the B, N, E or B, A, Q is the I format, and the J is the J format. So please watch the branch video for this, how we can calculate. So that's all for this video, and I hope you can now answer your classwork and upload it